Welcome to Pacific States University's online lecture series for BBA 302, Economics for Business. Today, we are diving into elasticity and consumer choice. We all know the basic law of demand, right? If prices go up, people generally buy less. If prices go down, people buy more. But honestly, if you're managing a business or setting public policy, simply knowing that demand falls when prices rise just isn't enough. We need real mathematical precision. We need to know exactly how much quantities are going to shift when you change a price tag. And to truly understand that, we have to look beneath the aggregate demand curves and figure out what is actually going on inside a consumer's head. We need to decode their psychological decision-making process. That is precisely what we are going to unpack in today's session, covering chapters 5 and 6 of our text. Here's our roadmap for today's lecture. We'll start by locking down the fundamentals of price elasticity, then we'll move on to some extreme cases, explore other types of elasticity, dive deep into consumer choice and utility, and finally wrap things up with a really crucial concept: income and substitution effects.
Let's jump right into part 1, the fundamentals of price elasticity.
Okay, so let's think about that foundational law of demand again. It's an inverse relationship. But imagine you run a local coffee shop and you decide to raise the price of your signature latte by exactly $1. The big question is, will you lose 5% of your daily customers, or are you going to lose 50%? That right there is where elasticity comes in. It answers that absolute, critical, how much question. So what exactly is price elasticity? Well, put simply, it is calculated as the percentage change in the quantity demanded of a good or service divided by the percentage change in its price. Conceptually, you can think of it as a ratio. It measures the proportional reaction, the sensitivity, of consumers to a shift in cost. Think of it like stretching a rubber band. We want to know how much the market stretches when we pull on the price. Now, because price and quantity almost always move in opposite directions, one goes up, the other goes down, the actual math gives us a negative number. But economists generally report elasticity as an absolute value. We just drop the negative sign because we want to focus strictly on the magnitude of the response. A high absolute value means your consumers are highly sensitive. They'll jump ship if you raise prices. A low absolute value means they barely bat an eye.
Now, to calculate this in the real world, economists use a specific mathematical approach called the midpoint method. You might be wondering, why not just use a standard percentage change calculation? Well, think about this. If a price goes from $10 to $15, that's a 50% increase. But if it drops from $15 back down to $10, that's only a 33% decrease. That asymmetry creates massive headaches for economic modeling depending on which direction you are moving on the curve. So we use the midpoint. Here's how it works, step by step. First, you identify your starting and ending quantities and prices. Second, you calculate the average quantity and the average price between those two exact points. These become your midpoints, your base. Third, you determine the percentage change by taking the difference in quantities and dividing it by that average quantity. And you do the exact same thing for the price. Finally, step 4, you just divide the percentage change in quantity by the percentage change in price. Using the average as the base guarantees a beautifully symmetric calculation. You get the exact same elasticity number regardless of whether prices are rising or falling between those 2 points.
Let's see this in action. Take a look at the calculation on the screen here. We are measuring the price elasticity of demand between two sets of points on a standard straight-line demand curve. As the price increases from point A to point B down at the lower end of the curve, using our trusty midpoint formula, we find an elasticity of 0.45. Okay, pretty low. But if we calculate the elasticity further up that exact same line, moving from point G to point H, the elasticity jumps significantly to 1.47. This is a really crucial light bulb moment for a lot of students. Elasticity is absolutely not constant on a straight-line, downward-sloping demand curve. The slope, the physical steepness of the line, remains completely constant, sure, but the elasticity changes at every single point along that line. Why? Because the base ratios of price and quantity are constantly shifting as you move up or down the graph. Down at point A, the price is low and quantity is high, so at $1 price change is a huge percentage jump in price, but a tiny percentage drop in quantity. Up at point G, it's the exact opposite.
With the core math out of the way, we can officially categorize consumer behavior into two main buckets: elastic and inelastic demand. When your calculated elasticity is greater than 1, demand is considered elastic. This means consumers react dramatically to price changes. The percentage change in quantity is bigger than the percentage change in price. But when the elasticity is less than 1, demand is inelastic, meaning there's a very low responsiveness. So let's think about this logically. Why do absolute necessities fall into the inelastic category, while luxury goods tend to be highly elastic? Let's take life-saving medications like insulin. If the price of insulin literally doubles tomorrow, the quantity demanded will barely budge. Why? Because consumers quite literally have to purchase it to survive. There are no close substitutes. But what about a luxury, like a 10-day Caribbean cruise? If the price of that vacation spikes by 20%, consumers can easily just stay home, go camping, or delay the trip. They are highly responsive, leading to a massive drop in the quantity demanded.
Moving right along, let's head into Section 2, Extreme Cases of Elasticity.
Now we are going to push the boundaries of the model. Just like in physics or engineering, stress testing our economic theories at the absolute extremes helps us understand the outer limits of market behavior. The two theoretical boundaries we look at are infinite elasticity and zero elasticity. Infinite, or perfect elasticity, is a scenario where the quantity demanded changes by an infinite amount in response to any price change whatsoever. If you were to graph this, picture a perfectly horizontal, flat demand curve. Imagine a perfectly competitive wheat farmer. If they try to raise their price by even one single penny above the going market rate, their sales will instantly drop to zero. Why? Because buyers will just go to the hundreds of other identical competitors selling at the market price. On the flip side, we have zero elasticity. This is a perfectly vertical curve. It means quantity is completely, 100% unresponsive to price. No matter how high the price climbs, the exact same quantity is demanded. Think of a critically essential, immediate, life-saving surgical intervention. You aren't going to haggle over the price. You demand exactly one surgery, no matter the cost.
There's a third, really fascinating boundary case to look at, and it applies to the supply side, the constant unitary elasticity supply curve. On the graph here, you see a supply curve shooting straight out from the origin point of 0, 0. What makes this particular curve so special is its perfect, unwavering consistency. Between every single pair of points on this line, a percentage increase in price is matched by an exactly equal percentage increase in quantity supplied. If the price goes up by 28.5%, the quantity supplied goes up by exactly 28.5%. The elasticity ratio is perfectly 1.0 across its entire length. It's an absolute mathematical rarity in the real world, but it serves as a beautiful, clean illustration of price and quantity moving in perfect lockstep.
Let's ground all this deep theory in some real-world data from your textbook. Take a look at the elasticity of housing versus restaurant meals. Housing has an incredibly low elasticity of just 0.12, and gasoline sits right at 0.35. These are deeply inelastic goods. And it makes total sense, right? If your rent goes up unexpectedly or gas prices spike overnight, you can't just instantly change your living situation or stop driving to your job. You absorb the cost because you have to. You're locked in, at least in the short term. But look down at restaurant meals. They sit at a highly elastic 2.27. If local restaurants suddenly double their menu prices, what happens? Consumers simply head to the grocery store and cook at home. It's an easily foregone consumption with highly available substitutes. So anytime you analyze a product's elasticity, always ask yourself, how easy is it for the consumer to just walk away or find a replacement?
All right, Section 3, Other Types of Elasticity.
Up until now, we focused heavily on how a good responds to a change in its own price. But remember, elasticity is a universal mathematical concept of responsiveness. It can measure how quantity reacts to changes in variables beyond just the price tag, things like consumer income. This is called the income elasticity of demand, and it allows us to classify goods into two distinct categories, normal goods and inferior goods. Normal goods have a positive income elasticity. This means that as your income rises, you naturally buy more of them. Inferior goods, however, have a negative income elasticity. As your income rises, you actually buy less of them. Imagine a college student who finally graduates and lands a fantastic, high-paying corporate job. With that new salary, they might start buying premium, grass-fed steaks at the grocery store. In this scenario, the steak is a normal good. At the very same time, they completely stop buying those cheap, bulk, instant ramen noodles they lived on during midterms. Here, the ramen is the classic inferior good. The demand actually drops as the consumer's wealth increases.
Next, we have the cross-price elasticity of demand. This measures the relationship between two different products. It tells us how the quantity demanded of good A responds to a price change in good B. First, we have substitute goods, which have a positive cross-price elasticity. For example, if the price of coffee suddenly spikes, you substitute away from it, which actively drives up the demand for tea. The price of one goes up, the demand for the other goes up. That's a positive relationship. Then we have complement goods, which have a negative cross-price elasticity. These are things consumed together. If coffee prices skyrocket, you naturally buy less coffee, which means you intrinsically need less sugar or creamer. Imagine if commercial plane tickets suddenly became incredibly cheap. What do you think happens to the cross-country train industry? The cross-price elasticity would mathematically track consumers substituting away from the rails and jumping into the skies.
Let's shift gears now to Section 4, Consumer Choice and Utility.
So we are going to pivot away from those broad external market forces and dive deep into the microeconomic mechanics, the internal psychology of individual consumer satisfaction and budget constraints. Imagine you are starving after a really long day of classes, and you order a large pizza. That very first slice, it offers massive, euphoric satisfaction. The utility you get is off the charts. The second slice is great, sure, but probably slightly less amazing than the first. By the time you force down the sixth slice, the additional satisfaction, what economists call the marginal utility, from that specific slice is practically zero. It might even be negative if you get a stomachache. This is the most foundational law of behavioral economics, the law of diminishing marginal utility. As a person consumes more of a specific good, the marginal satisfaction derived from each subsequent unit steadily and inevitably declines. It is the core mathematical reason why humans naturally seek variety in their lives rather than blowing their entire paycheck on just one single thing.
So, knowing this law, how do we as consumers maximize our happiness? How do we get the most bang for our buck? Take a look at point S on this table. We have a consumer named Jose, and he is choosing between buying t-shirts for $14 and going to movies for $7. At point S, the marginal utility he gets per dollar spent on his last t-shirt is exactly 1.6. And, crucially, the marginal utility per dollar spent on his last movie is also exactly 1.6. The ratios are perfectly equal. Now, what if he moved to point R, deciding to trade some movies for an extra t-shirt? Well, because of diminishing marginal utility, his marginal utility per dollar for that extra t-shirt drops to 1.5, while the utility for the movies he gave up rises to 1.9. Things get completely out of balance. This brings us to a major rule. Consumer equilibrium is mathematically reached when the marginal utility per dollar is exactly equal across all goods. At point S, Jose simply cannot squeeze a single extra drop of satisfaction from his budget by moving his money around. He is maximizing his utility.
Finally, let's explore our last and most advanced framework for today in Section 5, Income and Substitution Effects.
Pay close attention here, because we are unpacking the dual internal effects triggered by any price change. Every single time a price goes up or down, it triggers two simultaneous psychological reactions that alter how we buy: the substitution effect and the income effect. The substitution effect is relatively intuitive. When a price rises, that good becomes relatively more expensive compared to everything else, so you logically substitute away from it toward cheaper alternatives. Now, the income effect is a bit trickier and it trips up a lot of students. A quick heads up, the income effect does not actually mean your physical paycheck changed. It's all about your buying power. If the price of something you regularly buy, say groceries, suddenly drops, your fixed monthly budget can suddenly purchase more stuff overall. Your real purchasing power just increased. It acts upon your behavior exactly as if your boss had given you a raise. Whenever we observe a final change in consumer demand, we are actually looking at the combined net result of both these effects happening at the exact same time.
This can be tough to visualize, so let's carefully deconstruct these two effects together on a graph. Here we are tracking a consumer choosing between haircuts and pizza. Originally, they are happiest, maximizing their utility right at point A. Then, suddenly, the price of haircuts falls. Because haircuts are cheaper, the consumer's budget line swings outward to the right, and their new overall optimal choice settles at point B. But how exactly did they get from A to B psychologically? Economists use that dashed tangent line you see to isolate the two steps. We draw it parallel to the new, cheaper price ratio of haircuts, but we force it to keep touching the original curve of satisfaction. Moving along the curve from point A down to point C isolates purely the substitution effect. At this stage, the consumer is reacting only to the cheaper relative price, voluntarily swapping pizza for haircuts while maintaining their exact original level of baseline happiness. But wait, since haircuts are now cheaper, their total real purchasing power is actually higher. That is the income effect kicking in. The final jump from point C outward to the new curve at point B shows the consumer using that newfound buying power to boost their overall happiness, affording to buy more of both goods. So let's tie all of this high-level theory to a real-world policy debate. If a local government suddenly imposed a 20% tax on sugary soft drinks, I want you to think critically about how this would play out. How would this policy mathematically demonstrate cross-price elasticity when consumers look at alternatives like diet drinks or bottled water? And how exactly would this 20% price hike trigger the income effect, specifically for a budget-constrained college student whose purchasing power just shrank? By combining the hard math of elasticity with the internal psychology of consumer choice, you can actually start to predict the real-world impact of massive public policy decisions. Take some time to analyze that question before our next class. Thank you for joining today's lecture, and I will see you all next time.